In this quick tutorial, we're going to have a look at how one might fit a line to a histogram in Veusz. We've already seen one way to make a histogram in Veusz using the histogram widget. However, what this does is just work directly from the data that we have import without giving us actual values for the height of the bars, and so there's no real data to fit this to. If we wanted to fit a line, we would need X values and Y values. So I would need the position of each one of these bins as well as their height. And that's not included. We just have the data that we have import. And so if we look back at that data, we'll see that we just have the year and the returns. And so when we've generated the histogram, we've counted those up and made a plot that looks like this. But we don't yet have the data to fit to this. So how could we get that? Well, we could go back to the data and we could manually go through and bin this using formulas inside Excel, and that would work and that would be fine, but we can also do it in Veusz. So let's just make a new page to see how that works. We also need to have a set of axes for this, and essentially what we're going to do is we're going to make a bar chart where each one of the bars is going to have a height that's similar to what we have here in the histogram, and then a position that is the returns. What we would like to do then is take the data we have and divide it up. And we can do that automatically inside of Veusz, essentially processing the data by going to the data option in the top menu and going to histogram. Here we can say, how would we like to divide this up? And we start by selecting what we want to divide up. Let's do the S&P 500 returns. That's what we would like to bin. Then I could say that the output bin height, because we're going to generate new data, is S&P 500 count. So that's how many times we've seen this return. And then the position, we'll just call it positions. That's where it's going to be along the X. You'll see this in just a moment. Let's have the number of bins. And we're going to run from -1 to 1, just like we did in the histogram we saw a second ago. And if we wanted to divide that up then into even intervals, we would need 20 bins. Not 200, but 20. And then let's calculate the counts instead of the density or the fraction. And we don't want it to be cumulative. So we are now done. And so what I can do is say apply. And when I hit the apply button, you'll see new data appear over here called S&P 500 count and S&P 500 positions. Apply. There they are, count and positions. And now what this data is the number of times we've seen a certain year and then where to plot that along the X. So let me go ahead and close this dialog and let's make that plot. Essentially along the X, what we want to do is have returns. So that's how well we did. And then Y is the number of years that have that return. This is our histogram. Under the bars, then our lengths are going to simply be the S&P count. And then we have this that looks like the histogram we had before, except we don't have everything in the right spot. Before this ran from -1 to 1, which is what we were interested in. And so we need to give it its positions, and that's just simply the S&P positions that we calculated. Now this runs from -1 to 1, and we have all the bars. They're separated from each other, which is wrong for a histogram, and we've already talked about that, where histograms, the bars should directly run into each other. But we can fix this when I have bars selected under the formatting pane. I can say the bar fill and the group fill are both 1. And now they run into each other. Now I have something that looks a lot like the histogram that I started with before. And if I wanted them to look identical, I would just simply need to rescale the Y, which is the difference between these two. So this Y should run from 0 to 25 if we want it to look the same. We don't need it to, but let's just have it look the same for right now. And now we have two plots that look very similar. The difference is we have the ability easily to fit data now to these histograms. And so what I can do is say I want a fit line. We know what that is. It's this fit line widget. And then I need to give it a function. The function we're going to fit is to a Gaussian. And in the assignment, we had this formula here for the Gaussian. So let me just copy that and go back to views so that we have it easily input by saying paste. It's going to have an error because we don't have mean and sigma defined. So let's take a guess. Mean equals, well, let's take this tallest bar as a guess. So how about 0.2? And then let's have b, which is going to now be sigma, equals, and we'll just roughly guess that maybe the stretch of this is about 0.5. Again, we don't have to have a perfect guess yet. One thing that we're missing in this is how tall it should be. And so what I need to do is add a new factor, which will say, how about I for intensity? And then I will say I equals, how about I just start with the counts, even though that's not going to be right, just to get us in a general idea. 25. And now you can see we have this Gaussian. It's a little too wide, and if we wanted to play around with this, we certainly could. I could change the sigma to 0.2, and then we'd have something that looks a little bit narrower. This is now too tall, and so maybe that should be 1.5. We're not going to spend forever on this. I'm just trying to show you a little bit how this works so that you also understand what's going on. We're just changing the intensity. This looks like it matches pretty well. Of course, maybe I want to see the line better, so I'll move it up in front of the bar, and now I have this. The colors changed because we are defaulting to auto instead of having assigned them a color. And the auto colors things based off of their position in this stack. Okay, we're almost ready to fit. We haven't told it what to fit yet, but we know that the x positions are positions, S&P positions, and that the y is the S&P count. And now simply to fit this, we say fit function. What we get is a line that's very low. And the question is why? Well, the reason why this is because of the quirk we have in the fitting in views. And if you recall, what happens is when we're fitting, when there's no error, then views scales the relative error by the size. But we have several bars here that have a size of 0, which means that views is assigning them an error of 0. And we're attempting then to fit something that has this error of 0. So it's a problem with the data here for count. And so what we can do is we can go in and we can edit this and say compute error bars, apply, and now you'll see that everything has error bars associated with it. When we go into fit now and fit this function, we'll get something that looks much better. And so the issue before was that it was just assuming 0 error down here, and now we don't have that problem. And so, of course, we don't want to really show that error, and so we can go to formatting, and we can say that the error style is none. And then we won't have the error bars, but we'll still have this fit that included the error bars that allows us to have a reasonable fit to our data. And with that, we now have a histogram with a distribution that we have fit to a Gaussian function. And from that, we can get extractions about what we think the mean and the standard deviation is for this fit.